Thank you very much, everyone, for joining this morning. I know it's nice and early. This session is going to be talking about data engineering and basically how we interact with APIs now, compared to historically, where we had different types of mechanisms for getting data into our analytics solutions and so on and so forth. So there's various different things we're going to look at through the course of this. One thing that would be good is if you can just sort of stick a sort of thumbs up or a little wave if you are a data engineer at the moment and are interested in the topic. And I'll be looking down here at the little screen. So yeah, got a few coming in, which is good. So that's what we're going to be looking at. And then towards the end, we'll look at sort of where it's going and potentially some of the optimizations if you are building APIs that you can do to help us little data engineers when it comes to making our lives a little easier for data ingestion in bulk. Right then, so who am I? I'm John. I've been working in IT for nigh on 20 years. Worked for AWS, Microsoft, used to work for companies like SentryOne or done consulting. So got a broad range of experience across multiple sort of industry verticals, as well as technology stacks and types of activity. Contact details are there. Feel free to connect with me on LinkedIn. Drop me an email if you've got any questions after this or anything like that. For questions through the course of the session, feel free to, like I said, Ben, say come off mute, just sort of say hi and then do the question, we'll answer it then. Otherwise, if you don't want to talk, pop them in the chat. I'll have a look at the chat window towards the end and I'll go through the questions then and answer them, and we can have a more in-depth discussion at that point in time. Okay, and with that, like I say, really what we're going to be talking about today is looking at essentially the way that data engineering has changed over time. We're going to start thinking about how we used to get data out of platforms where we were dealing predominantly on premises back in the good old days of integration services, DTS, and what have you. Even some of the sort of more recent things with ADF and some of the other technologies, the way that we used to interact with things. And then what we're doing now, why we're looking at having to interact with APIs, and then where we're going into the future. So let's go back and start thinking about, well, how did we used to get data? And a lot of the time we were dealing directly with databases. They would be on servers that we hosted, that we used on premises. And we would be authenticating with SQL authentication, we were using Windows authentication. We running queries that were pulling in data from multiple tables, or we'd just be pulling in from views. Could be using discrete queries, or we could just be talking directly to the object, sometimes using stored procedures, pushing some of that sort of cleansing logic down into when we're actually pulling it in. And then looking at using particular tools, so a lot of the time potentially using something like integration services, DTS, for those that are sort of a bit long in the tooth like myself, Talent, so on and so forth. And then that would take that, they'd do a lot of transformation in line potentially, and then we'd drop it down into a database. Or if we were looking at doing data warehousing, for example, we were pulling it and dropping it into a landing schema and then evolving it through into the sort of structure that we would be expecting to build our reports off of, to give to our users, and so on and so forth. So that was predominantly the world that we worked in. The reason being, largely businesses used their or hosted their line of business apps on premises in their own data centers. And in that sort of scenario, what we're looking at is we had more control. We had a lot about, okay, well, we know what's going on behind the scenes as well. So we could do a lot more of that data activity. So in a second, there's a question or something come in the chat. Go, right. Oh, Ben just put the feedback link in, so that's cool. Right. Other options as well. I did work in several organizations where we had to do screen scraping, terminal emulators, some of the older sort of AS400 mainframe sort of platforms, ERP systems, manufacturing platforms. Lots of that would be a case of we'd have to spin up a terminal emulator. We'd be sort of scraping that out, dropping it to file, and then pulling that in, using things like EDIs. And then the other option is files that were put somewhere. I mean, we still do a lot with CSVs, or structured sort of text files, if you will, even if they're not CSV in the exact sort of format that we're dealing with. But a lot of those files would be either scheduled dumps from a platform, or in many cases, the sort of people manually running reports and exporting to Excel or exporting to some form of text file. So in that sort of scenario, again, we're dealing with something we've got a lot more control over. We're setting things up. And again, a lot of it is on premises. It's a lot of things that we were hosting, we were managing. We were the ones that were controlling how much resource was there, so that we could say, okay, well, we can interact with it at this particular time, because outside of that, we're dealing with business users and things like that needing priority for the resources. But again, we've got that control. If we want more performance, we just throw more hardware at it, or we optimize the queries in the back end. We do some database maintenance, things like that. So we had a lot of control, essentially. That's really what I'm getting at. And we could interact directly with the data stores themselves and more often than not. So again, thinking about historically what were APIs used for, a lot of the time it's really about interconnects between existing applications, passing data to and from them. I mean, we think about the whole point is an application programming interface. It's a way of interacting with that application without using UI necessarily. And we think about how the systems have evolved over time, and you've got sort of web services layer, you've got the front end communicating with the sort of APIs, API first. It is very application centric, which typically means that you're interacting with small amounts of data, individual transactions, if you will, in the database language, where you're sending something, you're getting a response, or you're sort of integrating it as part of a wider sort of business enterprise service bus, where we are passing messages around between different applications, and essentially it's used to bring all of our business systems together and integrate them effectively. So that would be things like Azure Service Bus that we got now, but I don't know if anyone remembers the good old days of BizTalk. I used to be a BizTalk administrator and developer back in the day as well, and being able to take that and build that logic in. But a lot of that was, again, very much about dealing with small subsets of data. When you think about what we're doing as data engineers now, we're dealing with large volumes of information. So you think about what we do now versus what the original intent of APIs was, they're not necessarily lined up in the way that they were built. And again, the sort of standardization of format between the source systems and the way that they're interconnected. So we'll talk about some of the options for the APIs later, but I mean, even then, EDI was used extensively between organizations. So it would be a sort of standardized file format that would be sent from one organization to another, but they were only standardized to a certain extent. The differences between US and European formats, potentially different ones between industries, depending on what's going on. Essentially, you have a library of these that you can do. So again, it's more about that sort of interconnect. And even with EDI, when you're sending bulk data, there's only so much that's being sent at any given point in time. Small files, historically, again, optimized because there wasn't necessarily the bandwidth between the systems that we were interacting with. So we think about how we get it from applications and why we're going to get it from APIs. So, I mean, there's still environments where businesses are running line of business apps on premises. You've got the app servers, you've got the database servers and the data stores. They're not necessarily all sort of relational databases anymore. There's a sort of rise of NoSQL environments and what have you. But a lot of the time, we're now having to sort of deal more with stuff where we don't have control. So we may still have stuff on premises or in our colos where we've got the database servers and we can interact with them directly at the database level. A lot of the time, there's also models where the vendors are hosting the databases. I have sort of worked at organizations where the third party has granted us access into a secure network segment, and we can interact directly with the Oracle database, with the SQL Server database, or the Postgres databases. But again, that's dealing with a lot more complexity because, again, it's a remote service, if you will, from where my integration servers will be, where the piece that I'm pulling the data back into is. So you start thinking about okay, well, what are the considerations there? I'm dealing with a greater distance, and laws of physics dictate that we're going to have latency. So again, we start to get to that point where, okay, well, it's not going to be as highly performing as if we've got them on our own equipment in our own data centers. We start dealing with these latency issues when we ask the data to be transferred. There's going to be bandwidth issues potentially, again, if we're doing bulk data transfers back over WAN links or sort of secure point-to-point VPNs potentially, things like that. So we start thinking about, okay, well, we're interacting with that. That's the sort of world we live in now. But a lot of organizations now host their line of business apps externally. They're hosted as SaaS. So we start thinking about, that's a big movement. When you think about the businesses you work with, the applications you use at home, for example, how many of them are actually installed? I mean, most organizations now have bought into cloud-based software, software as a service, for things like payroll, for HR, for pretty much everything. I mean, CRM solutions, you've got the likes of Salesforce, Dynamics, and everything like that. They're all hosted externally by the cloud providers. So what that means then is that we're going to have to interact with them via another mechanism, and that mechanism is typically an API. So what we think about there is, okay, well, how does this change what we're doing? Well, we're not going to be using SQL necessarily. We are not going to be in a position where we have the level of control. We don't necessarily have the same ability to sort of figure out which accounts we're going to be using. We now have to start looking at the ecosystem around that application, and we are dependent on what that provider has built. So we start thinking about and saying, okay, well, how do I authenticate? Well, historically, like I said, if it was on premises, we had SQL authentication, we had Windows authentication, or the equivalent sort of LDAP type scenario. We start thinking about our externally hosted services. You've got OAuth, you've got basic, you've got access tokens, you've got unauthenticated access, and it's all about understanding, well, what is that interaction? And even within something like OAuth and OAuth 2.0, there's various different authentication flows that will have a bearing on how we actually get the token, essentially, that allows us to connect to and authorize our access to the resources within that externally hosted application. And then we start thinking about the data formats. I mean, you've got the different types of API. You've got SOAP, REST, GraphQL as well, and different options for us to interact with. SOAP is not something I see very often anymore. I didn't see it too much in the past, in all honesty, but it was really geared again towards sort of discovery and more sort of small interactions between applications, connectivity between them as well, understanding and saying, okay, in that sort of situation, I'm going to send a message, I'm going to get a response back, but it's all XML based as well. So it was sort of semi-structured in that regards. REST APIs really came to the fore after sort of 2000, and through sort of the last sort of decade or so, really became the sort of de facto standard for interacting with many of those applications, and that's done over the HTTP protocol, which means that we're using sort of gets and posts and so on and so forth. So the standardization of that interaction. The responses we're getting back there, again, semi-structured. We can get stuff back as XML. We can get it back as JSON, get it back in binary format. There's the various different payloads. It's very versatile. And then GraphQL as well, which is a mechanism for interacting with, at a little bit more granular level, those APIs to pull data back as well. But we are at the mercy of whatever these application vendors have implemented. And that's the important thing to look at and understand, is to say, okay, well, which application are we using? And then where is the data? What is the data? What's the structure and the format? That's the thing that we need to look at and understand. And when we start thinking about some of the options that are out there, when we as data engineers tend not to have much say in the application piece when it gets brought in by the business. They're looking at functionality for the business users. Does it have the workflows they need? Does it perform the operations they need as a business? And that whole integration piece, a lot of the time, is just a tick box. It's like, does it have an API? Yes. Okay, but what does that actually mean for us? And that's something where, when we start as data engineers, we need to start getting more involved in that overall buy process and say, okay, well, yes, it has an API, but what does the API look like? How difficult is this going to be for us to integrate with? Because not all APIs are equal. There's different ways that things are implemented, for example. So things like pagination, the way that they authenticate, the way that you grant authorization, throttling, all of those sorts of things become considerations. We'll discuss those in a little bit more depth as we get into them. But essentially what we're thinking about is, okay, if we're going to need to pull this back into an analytics solution, or we need to provide some more important dashboards to the business because the stuff that comes in the application is not great, how are we going to get that? How are we going to be able to take that data and model it effectively and then store it? So I think as data engineers, we need to really start getting involved in that part of the process as well, and making our voices heard and saying, okay, well, we can go with this, but just be aware that there is going to be potentially extra effort after we look at the API spec and say, this is going to be more complex for us to work with versus less complex, and see if we can feed in that way as well. So if it has got good REST APIs with a relatively simple interaction for authentication and management, and then it also supports GraphQL as well, then that's going to make our lives a lot easier because we can do more with it versus this is just what you get out of the box with APIs, and these are the API endpoints, and this is what you get back in this structure, and then suck it and see. Okay. So we start thinking about the REST API themselves. One second. There's a chap called Roy Fielding, with colleagues that basically came up with a dissertation in 2000 that essentially gave us the spec for what a RESTful API should be. And it's about having sort of things like a uniform interface, for example. So you're using HTTP web verbs, so you get, put, post, delete, but they're common. Okay, so it's a standardized interface. You want to get information, you'll use the get verb, you send that data out, you get the response, and then you'll interact with the data. It's always sort of using web URIs as well. I mean, that wasn't the case with SOAP, but essentially we're hitting a web endpoint, something that can be addressed through DNS. And then when you look at the structure, and we'll look at them in a bit when we have a look in Postman, but essentially you say, here's the URI. So I'm going to github.com, salesforce.com, zero.com, .api or whatever, API dot, and then backslash, and then you've got an endpoint. So it could be, in case of things like Salesforce, you've got api.salesforce.com, backslash contacts, backslash opportunities. And what it means is when you do a get against that, you will end up in a scenario where you get a response, and it will have potentially JSON that sort of gives you a number of those things back. You've got the headers and everything that go with it. So it says, I pass in some headers that tell it the format I want and so on and so forth. It comes back, and then I've got it in a structure that I've asked for, along with some additional information about where I may want to get the next batch of information and so on and so forth. Okay. It's a stateless environment as well. So, excuse me, we're looking at it being sort of self-descriptive, and enough sort of context for us to be able to process that message effectively. It's a sort of client-server approach as well. So you've got a clear boundary between what's provided on the server side and what's sort of being received on the client side, the functionality that we have there when we're making those requests. And then obviously sort of cacheable as well. We want to look at sort of, we can cache that information on the client side quite easily. But again, it comes back to being stateless as well. So I can make the same request over and over and over. Sometimes we'll be using caching, what have you. Through those, and again, the response options that we're looking at, more often than not, we're dealing with JSON these days, just because when you think about the application itself, there's a lot of versatility on the application side, and a lot of customization you can make, add fields, remove fields, change data structures and things like that. You may not fill all of the information in, for example. So the data schema itself, I mean, anybody who's ever interacted with something like SharePoint and its sparse columns and massively wide tables and what have you will understand that that's not always a fun thing to be dealing with when you're dealing with a structured data environment. You start dealing with some of these applications and we start looking at saying, okay, well, I'm going to get that data back, but just give me everything that's populated, and that can vary between records as well. So again, that structure of the JSON may be larger or smaller for not only that particular call, but down within that itself between the records themselves. So for example, if you've got 3 addresses on one particular customer, then that block or that array of address for JSON is going to be there. Similar sort of concept with XML, but obviously XML is a little bit more verbose, a little bit more trying to say nicely, but it's not as pleasant. Let's put it that way. But it is more human readable. There is that element to it as well. But again, we start thinking about how we want that back. If that's been implemented, if that's the way the vendors implement it for their application, their API, then that's what we've got to deal with. So again, it's not we're going to get tabular format. We're going to drop it into a nice tabular format. We may get something back in binary format. We may get something back in XML. We may get something back in JSON. We may have some control over it. We may not. If the vendor has implemented a mechanism whereby I can request it to come back in XML or JSON, great. I can pick my poison and deal with it accordingly. Because when we think about what we're doing with these REST APIs and the way that we're interacting with a lot of it, I'm working with largely these days ADF or the pipeline equivalent through sort of, you've got Data Factory, Synapse or Fabric pipelines, and we're pulling a lot of that data into the data lake. So what we're doing by and large is we're taking that data, pulling it back in, and then just landing it somewhere into storage. And that format that we're doing, we can start making that choice again about, well, do I want to land it in a raw format, which in this case could be JSON, could be XML, could be tabular, could be binary. We're going to drop that down, or am I going to take that and part of my pipeline process will be, well, let's take that information and let's turn it into Parquet, to Avro, to CSV, or something like that that's more static in structure. But again, there you've got to understand what that implication is for that post-processing stage when you start ingesting that into the lake or the lake house itself, and the complexity that you'll have to deal with there. So it's a balancing act about, I've got to go to the API, I'm going to pull that in a particular format, then what do I do with it? Do I land it as is? I'm a big fan of just doing that, because that way it's very clear to see what we received out of the API. And in that case, we get a good feel for, okay, well, have we got good data, have we got bad data, before we start running our validation on it as we take it through the various stages of the medallion architecture. So again, that's what we're typically looking at dealing with when we deal with these things. So, and as I said, becoming more and more common with various applications being hosted externally now. So we start thinking about GraphQL. This is a more recent development. Facebook came up with it in 2012 and essentially open sourced it back in 2015. And it's a query language for APIs, which can be useful. Now, you will see certain APIs that implement a potentially SQL-like language or interface, sorry. So things like Zero, things like Salesforce, they've all got the ability to say, oh, I just want everything out of a report, or I want everything out of a particular API endpoint, which relates to a data entity or object within the application structure itself. And in that sort of scenario, it's okay, well, I'm going to get everything back. Or if I'm going to use that query language, do I get it back in a tabular format? Because that's what the response is, and that's the way it's being interpreted potentially. Whereas with GraphQL, again, we can be a little bit more reticent, or not so much reticent, but more focused on what we're pulling back. We can go in and say, actually, I want to query this API endpoint. I want to put a where clause on it. I want a particular number of fields, things like that as well. So really, we're sort of looking at solving that problem around the sort of over and under fetching that may exist. So when you start thinking about, say, about the lake house and the lake architectures, where we're commonly interacting with it as a data engineer and saying, I want to pull that information from a lake. If we go with pure REST APIs, then I've got to go in and I'm going to pull back everything for that particular endpoint, and then I'm going to drop that. Now, some of those sort of REST APIs have the ability to say, I want to pass a parameter in the URL or potentially in the header, or potentially another way to say, I want to limit it to everything since the last time I ran this. So you start thinking about high watermarks and the way that we track which data that we have brought in. We look and keep that stored somewhere in our metadata framework, and we say, okay, well, next time we go, I want to say, give me all of the contact records that are here since this date. Sometimes that exists, sometimes it doesn't. When we look at some of the examples we're going to look at when we jump into the demos in a bit, that's one thing we'll look at and see how those options are. There are sort of date fields there, but is it a case of I've got to go and get everything, drop it down, and then calculate the deltas from there as part of my post-processing? Or is there a way that I can do it within the API itself and only pull back sort of smaller amounts of data? And that becomes more and more important when we start thinking about some of the constraints that we have when the API implementations, the way some of these vendors have implemented things like throttling and what have you to protect their services. So that's something to think about as well. But we want to make sure that we're really pulling back only what we need, and GraphQL can really help with that if it's been implemented by the vendor. So the other thing as well is GraphQL is just sort of strongly typed as well, where you've got a lot more control over what's coming back and what information you want and the types and everything. So you can set variables up, you set data types and pass that information in. Whereas with REST, it's a case of give me what's on the endpoint and it comes back. So I mean, there is the server side element to the work on the GraphQL, sort of schema driven and what have you. So that makes life a little bit easier as well. Okay, I'm just going to look at the chat and see if we've got any questions. Nothing yet. Okay, that's always good. So with that, come on, we will have a quick look at some bits and pieces here. So if I minimize this, bring up Postman. So what I'm going to do here is I've got Postman. It's a little API app. There are several others out there. Whichever way you want to look at it, I'm using this just because it's a good mechanism for illustrating a point rather than a particular tool that I'm espousing you should or should not use. Just be aware that when you deal with APIs, and we'll look at the authentication minute, you're going to be putting secret information in there. And what I mean by when I say secret is things like authentication tokens, which will grant access to those resources. So you just be very mindful about what that is. If you're in non-production environments where you've got sanitized data, you may be more willing to put them into these tools versus production data. You want to be very, very careful about where you're storing those secrets, because obviously if you're putting them into something like this, where it's a cloud-based storage, or you're putting it into something where it's storing in local files, just understand those risk vectors. Okay, so that's a caveat when you look at using these tools. But Postman is the one I've been using for a while. It's the one I'm comfortable with, so that's the one we'll have a look at. So if we zoom in, got a couple of little bits and pieces here. We'll start off with the unauthenticated side of things. We're going to be using the GitHub API because it's quite a friendly one to work with, in all honesty. So first and foremost, I'll quickly sort of say what we've set up here. I've got some global variables. Now, typically when we deal with and interact with an API, we're going to have a base URL. As we say, it's predominantly using the HTTP protocol. We are interacting with it via the URL, and the base path is this bit here, which says, okay, well, this is going to be the constant part of the URL. And then everything to the right-hand side of that is something that may or may not change depending on which part of the API we're interacting with, the different endpoints we're interacting with, the objects that we're interacting with, what we want to pull back. Okay. Below that, API version. Now this comes down to, if we look in the API, start again. One of the things to understand is if we're going to interact with the API, you're going to have to go and read the documentation. It's not something that is necessarily easy to go and do discovery on, because not every API is the same. Okay. And going off and reading documentation is vital. Okay. Keep up to date with that. Because you'll have certain things that you have to put in order to make it work properly. So we've got the API path. That makes sense. API version. Excuse me. The API version. Okay. This is something that is very useful, and it's something that I think as data engineers we should be adopting when we're building our data products as well. But that's a talk for another time. Or we'll cover it maybe towards the back end of this one. Let's see. But essentially what we have is the API is versioned, which means as they increment on their application side, they can increment that version without necessarily breaking everything. So you think about the way we used to work with the databases. We deploy new tables, we deploy new views, we make some changes, and then we have to understand, okay, well, what is the sort of custody chain of that data as it goes through the various different pipelines? If I've got ETL processes which are extracting data from a view and I'm changing that view, the scope for testing, the scope for having to do additional work. So if I make those changes in the source database and then go down and say, what have I got that's consuming it, and do I need to then modify that and look at that? It can be a very complex environment. With the APIs, they do the version increment. If they increment to a new version, I'm passing in, I'm using version A, they've got B and C, which are live, then I've got time to say, actually, now I can do more comprehensive testing. I can move in my own time to version B to version C. Just be aware, however, that older versions can be deprecated and removed. So you need to, again, keep an eye on everything. What's going on with documentation? What are we doing with regards to the deprecation announcements? So there is that part of the development life cycle that we need to take into account. Okay, so the most current one at the moment is the 28th of November 2022 version of the API. So it's not always the dates. It could be version 1, version 2, version whatever. So you start dealing with some of the API versions for some of the Azure services, for example, like Key Vault, then you've got a version 7.0, that type of thing. Okay, so just be aware, again, not standardized. The API version key, these again are additional headers that we'll pass in. Now, when we start thinking about interacting with that API, we've got the headers, we've got URL parameters, we've got the body, and depending on what the spec of the API is, depends on what values we need to put in various different places. Okay. So the way it goes in for this one is these two are intrinsically linked for the GitHub one. So when we start constructing our header, I've got to basically say, this is how I'm telling it which version key I'm using. So it's a key value pair, if you will. This is the descriptor. And this is the value. Okay. So those all go together to say, this is the version of the API that I'm interacting with for GitHub, and that's what I'm going to be querying. That's what I'm going to be getting the data back from. Okay. And then the accept header. This essentially is saying, what format am I looking to accept that data in? And we've got here, it's a sort of GitHub JSON format. Okay, so again, it comes back and says, this is what I'm expecting to receive back. So when we start dealing with that in the tool. Now, that's on my globals, because in Postman, I've got multiple different collections, but this is something I want to be able to access from all of them. I've also set up a couple of little environments where I've got something specific. So the personal access token and OAuth setup. So we go to the PAT. This is an access token which you set up. Give me 5 seconds. What I'll quickly do is come to here, go to GitHub. If I go across to my profile, settings, and then down the bottom here, we have developer settings. We come into here. Okay. This is where I can say, okay, well, what am I setting up for my authentication to be able to interact with GitHub? Now I've got GitHub apps, OAuth apps, and personal access tokens. Go to personal access tokens. I've got one set up here. Basically, when you set this one up, you can say, I want a personal access token, which I'm going to be able to provide, which kind of acts as a surrogate for your username and password. Once you create it, you only ever see the value once, so make sure you put it in a secret store that you've got access to that's nice and secure, because then you can set up the permissions that are granted when accessing with that token. You can also set up the expiry. So this one is set up to expire on August 5th. So you can say, I want it to live for a long time, I want to live for a short time. That's something as well that you need to think about from a security perspective is, okay, well, what is the life cycle? Think of it as a password rotation, something we should be doing in our applications. Back when we were running SQL Server and stuff on premises, I'd be cycling passwords on a regular basis. Similar sort of thing here is I want to renew them, I want to recycle them. But again, if they get compromised, I can come in here and I can delete them centrally. And then anything that's got that won't be able to access it again. So just think about how you want to set that up. Long-lived tokens and what have you are a bigger risk because, again, if something does get breached, then there is that bigger window for potentially having your data exposed. Shorter ones mean there's a bigger management overhead of making sure you're cycling them and making sure they are in the appropriate secret management places for your automated process to pick up and pull. So just bear that one in mind. It is a sort of which side of that do you want to put the management. There's also OAuth apps. So I've got one here, which essentially is a mechanism where I've got a client ID. Whoa, screen close up. The secrets that are associated with it, so I can create multiples of those if I want to. Whoa. But again, that's how I'll use this to actually go and get a token. So the process for OAuth is I will get this client and secret information. I will then request tokens via various processes to be able to say, I want to grant access. And again, from here, I can come in, I can revoke user access if I have, once anything's been approved and associated, what have you. So just bear that one in mind. So we've got those various different security options. When we look at the OAuth piece, I got my client ID and my secret. So those are information that I'll pass into my collections. So we'll go back to the collections. We'll start with the unauthenticated piece. So if I come to here, go to the authorization, we're saying we're actually using no auth authorization authentication piece here. And what I'm going to do is I'm going to go and hit the GitHub API. So in Postman, what I'm saying is I'm going to perform a get. So it's the REST API. I'm using a variable here, essentially to say I want to use the API base path because that's going to be consistent. Save me, I'm going to type that in all the time. And I'm going to look at the rate limit information. Now, rate limit essentially is a mechanism that organizations will put in place on their APIs to help mitigate sort of denial of service attacks, overutilization of resources, the noisy neighbor, that type of thing. Okay. But we're going to hit the rate limit API endpoint. So that's going to give us some information about where we are with our rate limits. You can see down here, we've got the headers, which we're going to pass in as well. Oops. Okay. And then as part of that, we're going to pass in the API key and value. So like I said earlier, we're telling it how and which version of the API we're going to use using the variables that come in and the format of the data I'm expecting to accept that data in. So if I send that, what we get back is a nice little lump of JSON. If we bring that down, we can see here that there's various different elements to what gets rate limited and the type of things that we're dealing with. So with GraphQL, as an unauthenticated user, I've got no ability to use it. Okay. If we start thinking about that one there, let's do that. Come back to a decent one. So we've got GraphQL and core, which is the really interesting one. You'll notice here that as an unauthenticated user, I've got a limit of 60 calls, and then essentially saying, this is how many I've used, how many are remaining. A lot of that is going to be time bound, so it could be per minute, could be per hour, depends on what the API spec is. Again, go read the documentation because that will tell you what it is. So that's when we start thinking about, okay, well, that's the unauthenticated side of things. So now if I come in and look at, let's do it with my access token, we think about what we've got here as an authorization piece. The authorization authentication piece, I'm passing in my personal access token, and it's called what's known as a bearer token. So in this scenario, when I put in the authorization header, I'm passing in basically the word bearer space and then the value of that token. So that's what's going to be sent in. I'm doing the authentication piece up here, just because it means I don't have to set it for every single one of these underneath. But if we look at the authorization, we're saying inherit from parent. Come back to the headers. Again, it's the same as it was before. Actually, if I do show hidden ones as well. So there's a bunch of bits and pieces that are hidden there as well. User agent. So that's something that needs to be provided to certain APIs as well, so they know what's talking to them, things like that. So if you're dealing with things like ADF, potentially, you may have to add that when we get there. So if I run send that message, running a get, this time we're talking to Octocat. So we get a little, like I say, we can get all sorts of things back. And this one just means that, yep, I'm working and definitely hitting the API. I get my little picture back, little message. So if we start looking at the rate limit again here, look at the authorization, the headers, we're all set up as we were. So we've got the rate limit, so on and so forth. If I run this, you'll notice now that I'm authenticated, I have a significantly larger amount of requests that I can make within an allocated period of time. So again, you start thinking about how we're going to interact with them, what level of authentication we've got, the varying degrees of trust that we're putting into this means that the application vendor will give us more resources. You can see now we've also got 5,000 GraphQL requests and things that we can put in there. Okay. Now let's get in and have a look at some of these. Here we go. We'll start with this, and I want to look at authenticated user repos. Okay, so what I'm going to do is for the authenticated user, which is the one that I'm going to be connecting as, so the context of my personal access token is going to know who I am. It's going to say, okay, well, give me all of the user repositories. Okay, so again, we start building up that URL path, which is going to tell us which parts of the API we're going to interact with. We've still got the API key and the API version that we're interacting with, and what we're expecting the data to come back with. So if I send that, we get a big lump of JSON back, and as I said, you can get a lot of complexity in there about what's going on. You got all the URLs, and this is all the values that come back about what we're interacting with and how we can use that to go and get other bits and pieces. Again, very application centric. This is about, if I make this call to the API, I get this information back, I can then perform some actions off the back of it. It's not necessarily structured for ingesting something in to build a warehouse, a lake, reports, whatever. I mean, we come down here, we can see some of the sort of discrete values. So when it was created and updated, the last push. So again, we can see there what the time formats were. We can come down here and see the size on disk. We can see things like watchers. Has it got issues enabled, projects enabled, downloads enabled, wiki, so on and so forth. Okay, so there's a lot that we can see there. And this is the other thing to look at here is you can see we have got an updated date. So last time it was updated. But we don't easily have a way of pushing that information back to say, okay, well, only show me what's been updated. Because when we're dealing with the repos collection, essentially, we don't necessarily get the ability to query that. We can pull back an individual repo that may have been updated after a period of time. So again, we think about how we're interacting with a collection or individual ones. Now, one thing to look at is we can pass in parameters, and I mentioned these earlier. So pagination parameters, the number of records I get back per call. So here I can sit down to 5. I think maximum is about 100 for GitHub, and that will vary again per vendor. Read the documentation. That's where we need to go. But you can see, okay, I'm going to look here at the data plat organization. So this is one I'm dealing with the organization, not a user now. So again, just think about that nuance about how you're interacting with the different parts of the API. And I'm going to say, show me the repos, but only show me 5 per page. Okay, so if I send that, here we go. Let me just collapse a few of these down. 1, 2, 3, 4, and 5. So 5 repos there. Okay, so there's a lot of information in on that one. We can see all of the details around it. But if we then look at the headers that come back, where is link? This one here. So from pagination perspective, it's okay, well, I've asked for 5. How do I get the next batch? Okay, and that's where, in this case, you've got a response header that says, here's a link. And if I move that across, okay, we get this one here. Okay, we can see what the next page is. So per page, and then there's an extra parameter called page equals 2. And the relative link essentially is next. Okay, there are overall 8 pages, and it's 5 per page, but the one to get to the last page is last. Okay, so what we can do there is essentially, if I come to here, if I copy and send this, go page equals 2 on parameters. Put that in there. Okay. You can see now this URL is now the same as the one down here. Okay, so if I send that, and then we have a look here, you'll see in the response header, I've now got previous, next, last, and first. So again, I can interact with those. Now, when we start looking at ADF and using its REST REST parameter, or sorry, REST connector, there is the ability to go in and say, okay, well, when it comes to pagination, how do we interact with that? This is a sort of RFC standard way of doing it, not implemented by every API. A lot of them, you can get lumps of XML back that have discrete values. You can get meaningless sort of chunks back as well of values that you need to plumb into a particular parameter to get the next page and so on and so forth. Documentation and read it. It's a lot more complex environment. But that's the sort of scenario we get into. And then if I come back and look at the main body again, we've got another 5 records of the repos, and we can interact with those and say, okay, well, what am I dealing with? Okay. When it comes to OAuth, click to authorization, we get a little bit more complex in this one. Okay, we've got the token there, which we've got to go and generate. Essentially, we do a request. So we're sending in the request headers. It's a bearer token, and information that we need to put in is going to be related to the way that we configure our OAuth app. Okay, so if we look at this one, we're going to say, okay, we'll give the token a name. It's an authorization code or various different mechanisms for, here we go. Are we passing in client credentials, password credentials? This comes down to the authorization cycle or methodology. Different types of things. So the authorization code, for example, you get a code back, which then you can get a prompt on a web page to go and put through. That's sort of like device authentication. Client credentials, I pass in the client username, client password. Then I receive something back that I can then authorize the app to get the OAuth token, which I can then use to authenticate against the API piece that I need to interact with. So again, you see it can be a lot more complex when we start getting into these pieces. So if I come back to do a rate limit check on this one again, let me just pick my OAuth environment. And again, we come in here and we can see, yep, there's our rate limit. You can see I've done 4 calls already. I've got this many remaining. So when you start thinking about interacting, building our processes for ingesting data, it can be very, very important to go and read information from things like the headers or the rate limits to understand, or how many have I got left, because you may end up getting throttled. And if that is a process where you're putting a lot of data in and you're cycling and iterating through loops, that can be problematic because you can get throttled, hit that point, and then where does your ETL process go? So you need some mechanism for saying, okay, well, where am I on this rate? Do I want to gracefully fail so I can restart from a point once my rate limit has come back to where it needs to be? Okay. So those are essentially the same sort of thing that we're looking at there. We've got the repos, authenticated users to go from there. Okay. Is this now? Okay. So where are we for time? Right. So we'll quickly go back to the slide deck. So that's just been a walkthrough of some of the API elements that we need to look at considering. Authentication and authorization, as I said, it's going to be different by most APIs. They're going to implement something. They may implement multiple processes, and you've got to pick the one that's going to be right for yourselves. Okay, like I say, think about OAuth token expiry as well. Some applications will have it as 20 minutes. So again, we start thinking about doing something with, say, ADF and the pipelines. I go in and I'm hitting and I'm pulling in one data entity. I'm iterating through how long is that going to take? Do I need to go and refresh that token in a period of time after every call or after every entity? How long are things taking? So when you start looking at implementing it in operational world, you need to be very aware of if you start seeing authentication issues, it could be because the bearer token has expired and you're not built in a process to go and retrieve the next one. Rate limits, again, they're also going to impact us quite heavily, especially if we're dealing with large amounts of data on initial pulls. For example, you may need to build in some wait logic. It can be very, very complex there for those large pools initially, then start looking at doing that minimal delta work. Okay, that's really important as well. So if you can find a way of minimizing the amount of data you're pulling back, either using GraphQL or if the API supports sort of URL parameters or body parameters or header parameters to limit how much data is coming back. So give me everything since my last high watermark. That's going to make your life a lot easier because you're not necessarily going to hit those rate limits. Some vendors do have a paid for tier where they'll say, actually, you pay some more money, you get some more requests capability. That's something to consider as well. And that's why I say we really need to start getting involved more with that sort of buy process to understand the impact that's going to have as data engineers when we are working with our sort of businesses. And as a consultant, again, something to consider. Okay. For brevity, we'll think about, okay, pagination results. Again, we'll deal with that one. We won't go into that much. We've got time. We'll start thinking about what the future holds. More use of GraphQL. I can see that coming, really. That's going to make our lives a little bit easier. If there's a GraphQL API endpoint, seriously look at using that potentially over the sort of standard REST APIs. It should just make our lives a little bit easier in that regards to understand how that's going to work and what we're going to be doing. The APIs on analytics services like Fabric, we're actually going to need to interact with. So we think about the way we do deployments at the moment to services. We're doing database projects and things like that, but interacting with services like Fabric, yeah, we've still got some of those CI/CD processes we can deploy database schemas and practices. But think about deploying the Power BI elements, semantic models, all of those sorts of things. A lot of that's API driven. A lot of it's going to be interacting with as well and dealing with, because Fabric's more of a software as a service versus Synapse, which is more traditional service-based approach. Again, we want to interact with it. We want to do some configuration options. We want to think about, okay, well, how do I reconfigure something as part of an automated pipeline, do the deployments? We're going to have to interact with those APIs from a configuration aspect as well with some of the things that we're building and managing as we go forwards. So that's something to be thinking about as well, where we may have to sort of build a blended pipeline where we're doing something with infrastructure as code with Terraform, Bicep, what have you. And then we start thinking about, okay, well, we need to do the deployment, we're doing a build, and then create the artifact, deploy the artifact, and then we've got another step in the pipelines where we say we're actually going to be configuring the application. We're going to change some of the settings. We're going to do that through the API. So again, we think about how we're going to interact with those over time. If you are in a position, if you're a developer and you're developing new APIs, please bear in mind the way that organizations work now. They want analytics solutions. A lot of them are going to be cloud-based. Building APIs in a way that facilitates the extraction of bulk data is going to be very important. It's going to be something that that data engineers are going to be doing on a regular basis, especially as businesses are now using more external applications, using cloud applications. So, I mean, there are some out there that use an asynchronous method where you can send a job in, it will then do the work and then send that back. So we're moving from a synchronous to an asynchronous type in activity for us data engineers. It's something we need to get our heads around as well. It's not just issue query, get response. It could be issue query. Is it ready? Is it ready? Is it, yep, got that data, pull it back. Developing APIs, bulk extraction, what's going to be an optimal format to send that data in potentially. You want to send it back as a binary lump, then that could be quite large. Think about hundreds of megabytes, potentially gigabytes of data coming back and needing to stream that out. That's going to be a lot of bandwidth. We start thinking, if you're a SaaS provider hosting in Azure or AWS or something like that, that's going to have a ramification for data leaving you for your costs, but also then for thinking about some of the things that the users are going to be doing when they're moving data in between data ingestion, data storage, that type of thing. Another option might be to say, okay, well, I will take the information into my API and you pass in a S3 bucket or a Azure Blob Store location, and I will construct the data and I will put it in that Blob Store for you. So just be a little bit more creative about how you're building the APIs and what we are looking to try and achieve with them. It's not just application interaction now. It is very much a case of, okay, we want to deal with bulk integration, we want to do reporting, we want to do data lakehouse activities. The other thing to consider as well is the authentication piece. These ETL tools like Data Factory, like Talend, Airflow, these sorts of things, when we're doing sort of OAuth, a lot of those processes are very sort of user-centric. So it's a case of I do something, I get a response, I get a browser window, I push yes, authorize. Start thinking about more of a sort of headless application process for those integration of facilitating that, because the setup can be problematic, especially if we get out of sync with tokens and we've got to go in and manually interact with things, put things into the secret stores. So again, think about how that authorization, authentication piece for retrieval of a token to be able to do that work is going to work. And again, think about when you're building your applications, how can we manage the sort of cycling of tokens, cycling of whether they're personal access tokens, whether they're OAuth tokens, what's the best way to cycle through and do that in a way that is as hands-off as possible, but not built. We don't have the richness of Python, of C#, of Java. We're dealing with ETL tools. In certain cases, we may be able to use Python in notebooks, but again, that's a little bit more bespoke. A lot of these ETL tools, like the pipelines tech, have the ability to do a query, a connector that goes to the REST API, but they're limited in what they let us do. So that's been my session. I think we hit right on time there. Thank you very much, everyone. I really appreciate your time. Have we got any questions?
So, Mr. John,
yes,
we have one question from the audience, from Bish. Which would be your preference in an ideal world? GraphQL or JSON or XML?
So GraphQL will give you, in the case of GitHub's GraphQL API, it will give you JSON back. Of the two, JSON is the least worst option. I think is probably the best way to put it, coming from someone that likes dealing with tabular data sources. If there was a way to get Parquet back by default, I'd be very happy. But of the two, JSON's probably the easier one to work with. It's got more support in most of the tools, and also most of the platforms. I know Databricks recently added XML sort of as something that it can talk to and use, but it can be, because of all of the tags in there, it can be quite bulky and actually overinflate the amount of data you're pushing around. So from the overall perspective, I would probably say JSON's my preferred responsive choice out of them, having to go down that way. So that's cool. Preferred ETL tool to load data from an API? It depends. Can you tell I was a DBA? I've done a lot of work with, as much as I malign ADF and the pipeline equivalents in Synapse and Fabric, my view is they're the best on the market. and it's probably the easier one to work with. There are things like Talend, which is a very capable platform, and various things for Informatica. You've got Apache Airflow. ADF and its equivalents in the Microsoft ones tend to make it an easier platform to use. From a developer perspective, it's nice. If I have to, I would use that first, and then I'd drop into something like Python. So if I'm using a service where I can put Python into a notebook, or I can run a Python file, a script file, then I would look at saying, okay, ADF first, and if I can't do what I'm needing to do there because it's a particularly complex API, then I'd look to do and write that in Python in a notebook. Would probably be the best way to look at doing that.